Good evening, all. Very warm welcome to all of you. I'm Dr. Juhi Yasmin, Assistant Professor of Communicative English, Department of CI, CSE, AI and ML, and Cybersecurity, Faculty of Engineering and Technology, GENE, deemed to be University. I'm here to welcome you all to today's Industry Connect session. Today's session is on cybersecurity, and the title for the session is Cloud Virtualization. Today we have with us an esteemed guest speaker, Mr. Sandeepan Chakraborty, and he is the senior technologist with 20 plus years of experience in consulting and execution of digital transformation, domain solution architecture for automotive, oil and gas mining sector, government enterprise architecture, fintech, IT service management and technology program management for complex system integration initiatives of Wipro, IBM and PwC. And Mr. Chakraborty has also performed different senior level technology consulting and execution roles as lead solution architect of energy digital transformation program and AWS cloud migration in British Petroleum. He is also heading the India service management team for Maximo and IBM. He has also developed a strong client relationships by earning their trust and goodwill, which had resulted in creating considerable mindshare. Also possesses an experience on evangelizing impact of digital transformation, IT for IT, Agilis and Scrum, methodologies, best practices, and helping technology organizations adapt to digital change. So, on behalf of the entire Jane family, I would like to extend a warm welcome to you and would like to thank you for taking out your precious hour to be spent with us. Our today's audience is students of BTech Cybersecurity, BCS students, as well as faculty members of the same department. So now is over to you, Mr. Sandeepan, to just start the session and give us the insights about the topic.
Sure. Thank you so much for having me. It's a privilege.
It's an honor. It's an honor, sir, to be
so
have you here. Yeah, thanks for joining.
What I do is, am I audible? Can everybody hear me?
Yes, sir. You're audible, clearly audible.
So, I'm going to talk about one of the main fundamental blocks of cloud, without which the properties or the basic principles of cloud engineering would not have taken shape. So this is to do with the virtualization. This technology has revolutionized the way we build cloud solutions, cloud native applications, the way we scale, and lot of the enhancements, lot of the technological progress that the cloud has enabled in today's world is due to virtualization. So I'll start with a little basic and what we understand by virtualization. So fundamentally, there are two types of virtualization that we come across. One is using the operating system to be virtualized using an hypervisor. The other is using a virtual infrastructure manager, or what we call as a VIM, to virtualize the hardware by using an intermediate layer called hypervisor without the use of guest operating system, without the use of the host operating system. So if you fundamentally look at it, there are physical devices, physical storage devices, physical application servers, network devices, and there is a software which is able to abstract all these hardware devices and basically using a VIM, or a virtual infrastructure manager, or sometimes it is called VMM, virtual machine monitored. It's able to create these virtual machines, allocate storage to these virtual machines, and spin the new virtual machines of different capacities, different configurations. A typical example is the cloud service that we come across today. So everybody has, using or consuming some sort of cloud service, and behind the scene, there is a resource, a cloud resource or a server, which is hosting that service. And that server is basically a virtual machine, which is um, a replica of a disk image of a physical server, which has been created by the hypervisor. So there are, see, if you look at this model, you'll see that there are physical servers. There is a hypervisor layer, which is used to abstract the hardware, and there is a guest. I mean, these virtual machines are hosted by having multiple guest operating systems. A more clearer version, let me walk you through what this virtualization does. We have at the bottommost of the physical layer, we have the hardware devices, which comprises of the storage devices, network devices, and we have a host operating system, which is any of those physical devices will have an operating system, be it Linux, different flavors of Linux, Windows, CentOS, any of these. And what this host operating system essentially does is it creates a layer for the virtualization to happen. Virtualization is done using a binary file. So each of these physical servers, we can create a virtual disk image, which is nothing but a binary file, and the application software, like if it is a Windows machine, then there will be an application software which will be packaged with that binary image. And the whole package is made into a virtual server. So there will be three things here. There will be a virtual hardware, which is the hardware component which has been abstracted, and a disk image has been created out of it. There is a guest operating system which is built into that image, and there is an application software which is also built into this image. So there are three things that are comprising of the virtual disk image: virtual hardware, guest operating system, and the application software. So all of these constitute what we call as a virtualized machine. So fundamentally, it is nothing but a file which is a disk image comprising of the application software that is used to run different applications, primarily the guest operating system, and it is packaged into a bundle. So this is what we term as the server consolidation. What is the word? The server consolidation is where we have physical servers being consolidated into multiple virtual machines running different guest OS systems. So we can have one virtual machine where we have created an image from the host operating system, having, say, Linux operating system, along with the application software, which is could be the runtime environment of Java, or it could be a runtime environment of Oracle, or any of the application software needed to create a working virtual machine. So if you look at the ways that I was referring to of virtualization, there are two main ways. One is virtualizing the guest, I mean the physical devices, the storage device, the network device, and having an host operating system which will basically talk to this device layer, the physical layer, and abstract a lot of the kernel level calls, the driver connectivities, and expose a layer which is the completely hide the hardware part from the guest OS. So if you look at it, I mean, from a simple view model, these guest operating systems running in the virtual machines do not have any idea about the hardware with which the host operating system is interacting. Now it is the responsibility of the host operating system to translate the different IO calls from the guest operating system of the virtual machines to communicate with the underlying hardware. So the challenge here is that the network overhead, if you look at the network kind of from a networking point of view, the devices are communicating to uh, the operating system at the host level, and then they are able to translate that call to the guest operating system. So there is an overhead, networking overhead, which is causing uh, um, minor latency. And the, the the plus point, or the pros of this is the host operating system can actually translate or it is compatible with the hardware device drivers. So if you look at from a hardware point of view, you have the storage devices, you have networks devices, and all of these are running a user driver, and this driver sometimes, is basically, the closer your operating system supporting the driver, the faster your performance. So virtual machines, because they rely on a host operating system to do the translation of the calls, though the latency is induced, but there is a performance, perhaps performance is enhanced, because uh, all the modern host operating systems like Unix, Linux, um, Windows, they can support a wide range of device drivers. Okay, and that's one of the plus points of having a host operating system as uh, as a layer for virtualization. So this is the plus point. Then the other way of doing the virtualization is to completely eliminate the host operating system, because a lot of the calls uh, get uh, are impacted by having that additional host operating system translating the calls to the devices. So in order to overcome this, there is a way in which we can do a direct uh, hardware virtualization. So if you look at the difference, there was the host operating system in between. Now I will use the hypervisor directly to interact with my hardware devices. And the flip side is the hypervisor does not support, or sometimes it has come to a situation where some of the devices may not be able to operate or make calls from the guest operating system to the hardware, because the hypervisor is not so compatible, so much compatible with the devices. Now, even though the different file formats for having hypervisor like OVF, what we call the open virtualization format. Uh, Even though that is possible, but yet there are some gaps, and some of the devices actually may not be compatible with the hypervisor software. Just to get you a sense of different types of hypervisor software, if you look at it uh, in the different platforms that are able to create virtual machines. So in Microsoft platform, if you are running Windows Server operating system, then hypervisor is called the Hyper-V, and the Citrix hypervisor is for the Citrix hypervisor software. Google uses KVM hypervisor. Amazon uses Nitro. So as things, there is an industry-wide effort to standardize the virtualized file format, which is called the open virtualization format, and ensuring that all the devices and the drivers are compatible. Now let's say sometimes what happens is um, there is a remediation which is needed. Like I was saying that the hypervisor software may not have the capability to communicate with certain drivers, and that thing is remediated by using what is called as a para virtualization. So you're not really eliminated the host operating system, but introduced an interface which is called as a para virtualization API to talk to the drivers and ensure the compatibility issues between the guest operating system and the support with the hardware is resolved. So this is a important feature where sometimes we use this virtualization drawback to be addressed using this para virtualization API. So now the point is, in the cloud engineering space, virtualization has also created a multitude of problems, and more so from a security standpoint. See, one is that we now live in a world which is totally interconnected in the real sense, because every network talks to the other network, and in every network there is a certain degree of overlap with the network of another virtual machine. So what it really means is that if someone who is trying to who is an administrator of a virtualized environment gets an unauthorized access to the hardware, then that might be a cause of concern. So therefore, virtualization attacks what we call as getting unauthorized access to the hardware from a authorized from a system admin or admin who is having access to the virtual machines, is opens up one threat for attack, and will delve deeper into some of the security threats that happens due to virtualization. So see, now we have multiple cloud service providers, Amazon, Google, and we also have private players who are offering similar services, similar managed cloud services, competing with the likes of these global players. So, so what happens is that there are lots of security risks which need to be answered. One is, of course, the unauthorized access to the virtual server, and in turn to the hardware. The other is the overlap of the network. So if two cloud services are being exposed by two different cloud service providers, there is a high chance of having an overlap in the network, which exposes some of the vulnerabilities of one cloud service provider to the other. So this is called as a trusted boundary. So every service has a trusted boundary, and I've sort of shown it in another slide where there is something called as a network parameter, and that parameter is very important. So from a security standpoint, I would just like to touch upon a few things. Whenever any agreement, any contractual agreement is made with the cloud service provider, we need to ensure that there is no threat of such vulnerabilities of attack from authorized users. We also take care of a lot of the indemnity clauses, right? So in case there is a data breach in virtualization, in accessing the physical servers or the storage devices of other customers. So the main thing, as we know, that virtualization leads to multi-tenancy, because the same physical server or physical storage or network can be used by multiple consumers. So there is a very strong potential of data breach. So how do you basically ensure that every customer is isolated, every instance is isolated from the other, and there is no overlap? So this is the what we call as a risk assessment, and especially in the case of third-party cloud service providers, we before signing contracts, we make sure that these objectives, these are very clearly addressed. And this addressing part, what we call as the risk control. So how do we control? How do you review? And there is a whole lot of things that that happens behind the scene. So one is the vulnerability, or what we call as the threat modeling. So every time a cloud service provider provides that infrastructure as a service, or a platform as a service, or a SaaS, even a SaaS, there is a fair amount of threat that needs to be assessed. How many, what are the role-based access controls? How are the security policies being managed? How are the MFAs, the multi-factor authentication, being used? How the keys being managed, the secret access and access keys being managed? All of these are carefully monitored and controlled. And how quickly, or how many times the credentials of the admin, or the people in responsible roles, how frequently are these rotated? So there is a constant check on all of these, and also to make sure that nobody has any physical access to the keys being used by another person, another analyst, or another admin, which results in a unauthorized access kind of a situation. So these are of paramount importance, and each are controlled and governed through a series of measures and steps. I will touch upon the infrastructure part, where the cloud infrastructure solution blocks. What we mean by to create this virtualization, what are the typical components that needs to be used? So if you look at it, there is a logical network parameter, there is a virtual server, and each has a meaning. So the logical network parameter, if you look at it, it is to separate, isolate the different cloud resources. So it establishes a boundary and also isolates cloud resources from users and non-users. If you are an unauthorized, you are not supposed to get access to those virtual servers. So this does what we call as in other terms as the demilitarized zone. So if you look at the um, the internet, the internet is a interconnected set of networks. Now, I can have in my organization, I can have a firewall which protects my corporate VLAN, okay, uh, from the public network. And then um, I have a perimeter which is around this corporate LAN, uh, which is completely secured and which is private. It is private to the employees of the organization. So this part, if you look at the perimeter, which I have dotted as red dots here, this part is called as a demilitarized zone. What it means is that this is a green zone that is highly secured and no unauthorized access to any resource, infrastructure resource will be possible. So this is gives rise to what we call as the network, which is established between these private networks. It's called the virtual private network. So again, the concepts are very important because this is one of the ways in which we avoid unauthorized access or any form of threats or cyber security threats by securing the two networks through a private connection. And the zone around it is called the demilitarized zone, or what we know as the logical network parameter. Any questions till now? Or should we complete and then probably we'll have a question answer session, right?
Yes, after completion of your session, we will have a discussion and question round with the students
Sure.
and
Sure.
our audience. Yeah.
Now, I'm going to touch upon these virtual servers and the virtual infrastructure manager. What is their role and how it works? So at the very bottom, you have the physical machines, servers, which are talking with the hypervisors, the respective hypervisors. And this whole thing is orchestrated through the virtual infrastructure manager. So this is a virtualization platform, what we call, and these are the different virtualized machines which are getting created by this virtual infrastructure manager, and suitable memory, suitable storage, suitable network bandwidth is provided to these virtual machines at the top by using VIM. So VIM is like the brain of all the virtualization that happens behind the scene using the hypervisor. Give you a sense of practical specifications and how virtualization helps is in order to build similar configuration servers. Say, for example, I want a virtual server which has one virtual processor, core, 4 GB RAM, 20 GB storage. So this is a template specification. I can create multiple copies of these specifications in the form of that image file which we just talked about. So if I create an image file of a physical server having these specifications and along with the guest operating system and the application software, I can create multiple copies of that disk image in OVF format, Open Virtualization Format, and basically run it in the virtualized environment. And each of these files can be multiplied to manage the scale of my operations, right? How many servers or how many virtual servers rather I need to handle the traffic, to handle the load. So I can, what this gives me is templatized or an industrialized specification which can be multiplied many times. I can have hundreds of these virtual medium virtual server instances. I can have thousands of these large virtual server instances. So as you see here, it is very easy to templatize the specifications and create disk images in the form of the open virtualized format, which can be replicated. So another word is very important here that comes out from virtualization is the fact of replication. And we will touch upon that very shortly. Now, cloud storage, we've talked about the servers, but what about the storage? So all the storage also can be virtualized, and each has the, the different characteristics. So if, for example, the network storage, we could have block storage in a network storage, or we could have a file storage in a network storage. Some of you are familiar, I think most of you are familiar with the NFS, the new file system, or the POSIX, which are the different protocols adopted by the file system management. And different block storage, which is the closest to the hardware devices, the actual physical storage devices. This block storage protocol is also supported for virtualization. So that means you can have a block storage to be virtualized and made available to the virtual machine. Some of the examples of the block storage protocols are SCSI and FC. So these are some of the protocols that use the block combination of block storage and file storage. Next is the object storage. So object is another way of storing data, and that can also be virtualized. So there are certain examples and certain protocols that can be used, like CDMI that can be used. And object storage is also another way which is very much in use in today's virtualization. So for example, some of you who are familiar with Amazon will know that S3 is an object storage. The simple storage from Amazon, storage service from Amazon supports the object storage. The database storage is how it's one layer beyond just the storage mechanism. It is how best you can store it, right? So there are plenty of examples of database storage, and there are there are platforms like say AWS has RDS, Relational Data Service, right, which are used as platforms by the consumers. So, and it supports fully managed database. That means you can take backup of the database, you can restore the database, you can manipulate in terms of the queries, in terms of the indexes. All these things you can do as a managed service, so that the consumer is just using the database for querying, but the database management work is being handled by the cloud service provider. And then there is the NoSQL database, which is exclusively for storing data. There is no other feature or function for querying, but it is to ensure that all the data is stored effectively and can be retrieved in a very fast performing manner. So the point here is that there are wide numbers of storage devices which can be virtualized and which are supporting all the protocols that we need for management of our data. The basic system, how it works, just to give you a sense of how it works. The request, if you see, let me, yeah. So there are what we call as usage or admin portals, right? This is nothing but every virtualized environment will have a front end where you can see the usage, where you can control the number of virtual machines that you want to create, a number of what are the different storage that you can allocate to these virtual machines. So a request always comes from a system admin sort of a persona who will allocate these resources. So who will interact with a portal kind of a front end, and behind the scene, this virtual infrastructure manager will start allocating block storage or file storage or any form of data storage to these virtual servers, virtual machines, and get this thing provisioned. So any, this is a very generalized view, but gives you a understanding of how smart provisioning of infrastructure through the virtualization happens in real world. So there is a user interface which is used, and behind the scene, the virtualization manager will operate and allocate these memories. So just to get you sense, you need to also look at how this usage of the software of the virtualized servers are being managed. When I say usage, what it means is your billing information, how frequently your servers are being used, that sort of information, right, needs to be also captured. That's very important because these services are, as you know, these services are pay as you use service. So you get charged for the consumption. Now there are two important things here. One is that virtualization has made it possible for a lot of service providers to virtualize or to create the infrastructure based on the customer's specification, and then the customer is charged or billed for these provisioned infrastructure, irrespective of whether it is being used or not. So it might be standing idle. You never know. You have a database server which is not being used. You have a web server which is not being used. But yet it has been provisioned and it is lying so idle. So it is very important that this pay as you use model, that is why it precisely came, that your billing has to be connected with usage. Otherwise, there is no billing. So that's what the slide, the next slide, if you look at it, we are going to discuss about the cloud usage monitoring. So how exactly your resources, the infra resources are being used. And it is not just infra resources, it can be your services also. So there are two things here. One is the infra resources. That means your storage, your network, your your servers. And the other is your web applications or your blockchain application or your mobile application. How much are they being used? Because behind the scene, there is also an infra, there is also a virtualization layer, and there is also a application layer. So all of these need to be monitored. Now the principle of monitoring is done through three ways. One is using a monitoring agent. The other is, we'll discuss this in the next slide, is using the resource agent. And then another agent which will continuously polled to get the right status of usage. So when we talk about the first basic thing, which is to monitor cloud service in terms of the usage. So here, any of the services that we as customers we are subscribing, there is a agent which can run behind the firewall, and this agent is running and polling and basically monitoring the service, the service which is receiving the request. So if you look at this diagram, it's a very oversimplified view uh, which talks about a requester who is looking for some uh, uh, web service, and this message, what is being sent in the request, is actually getting monitored through a monitoring agent. And this monitoring agent is writing onto a log database exactly what is getting, what the message is and how big is the message. uh, those kind of information or metadata is being logged into this database. Now what it shows, this database will actually keep tab of how much how much of the time this service request has been used. So monitoring is only capturing the data of the usage of that request, how long it has been used, and basically keeping a tab on that. And that is also going to be connected to the billing information. So how frequently your services are being used. So similarly, there is a uh, resource agent which we use to monitor the hardware resources. The first example was a service, cloud service application which is being used. Then we are now talking about the virtual server, the infrastructure which is being used. So in the same way, I will have a resource agent to monitor the usage of this virtual server. Okay, what is the duration of usage, and accordingly send the logs for billing. So same principle, serving the two different purposes. The other is the polling agent. So what we do, I mean, these are adopted universally, whether it is Amazon, whether it is Google, whether it is Microsoft, Oracle Cloud, all of these giants have the same basic principle. The principle in the industry doesn't change. What it happens is there is a polling mechanism which is an event based. So each time I have a virtual server being provisioned by my system admin, a trigger is sent out, and then continuously uh, the service, the cloud service is polled for uptime. So for example, we are going to be charged for the uptime of the service and the service consumption. So it will keep a tab on what is the duration of the uptime of the service for, and then relate that to the billing, so that you get a very clear picture that once the virtualized server was up and the cloud service was operational, because server up doesn't mean a service is also up. So if there is a flaw somewhere, then you should not be getting billed for it. That's the idea. Okay, so they are very closely related. Um, Now, the important point that I wanted to discuss also as part of this topic is the replication, because this replication technology has made it possible to scale. Otherwise, the cloud uh, applications that we are consuming, virtually everything has now been virtualized. I mean, in today's world, if you look at the internet, you can imagine that how many data centers are virtualized to create this internet scale of operation. So internet scale of operation means that I have, again, the principle is the same. The virtual server images are created in a certain specific capacity. These many virtual servers, processors, these many RAM, this many GB RAM, this many hard disk, and then we create multiple copies of that through the hypervisor. So one physical device can be allocated to 3 virtual servers, and one physical storage can be allocated to these virtual storage devices. Uh, so this gives us the ability to scale. And a good example, um, just to give you a sense, uh, the different deployment models that we talk about, IaaS, PaaS, and SaaS, the fundamental principle remains virtualization, because if you look at the infra as a service, here you are virtualizing only the infra. You are not doing anything beyond the infra part, right? There's a physical host and the 2 virtual machines being created through the hypervisor. But the moment you talk about the platform as a service, there is a further virtualization of the what we call as a ready-made environment, because the environment, the runtime environment is then provisioned for you on the virtual server. So it is one, you have the physical, you have the virtual machine. On the virtual machine, you have the runtime environment, you have the development environment, you have the middleware, and then it is as if it is a self-contained uh, self-contained platform where you can build your applications. So this is the possibility of virtualization. And then once you have virtualized everything, so just the only the service is exposed. So there is, the platform is done, the application is built on top of the platform. Now you are just exposing that service, that is called a software as a service. So de facto, each layer, if we think about it, it is abstracting one from the other till the point that there's only a single endpoint which is exposed over the internet. So such is the power of virtualization. Hope I'm making some sense here. So ready-made environment, where we use it, most of the time it's used in zero code or low code environments where we do not need to do much coding, and industries, software makers, they readily use these platforms to scale. So everything is given to you on a platform, your runtime environment, your middleware, and sometimes your business logic as well, so that you are responsible for nothing uh, except using it, right, and deploying your applications. So sometimes what happens is that you segregate your logical business logic as well in these runtime environments. So you might say that my front end will have a Java, could be a Java front end, or my backend system could be a microservice, and a front end could be an Angular JS sort of a mix. And the billing that that the consumer, the service consumer, will incur is different for the different logical groupings. So maybe, you know, the front end service, or the front end ready-made environment or platform as a service, however we want to call it, that has a lot more speed, because of the network, because of the way it has been provisioned and architected, that your billing, the rates are moderated, because you have too much of load, too much of capacity issues, and therefore you need to optimize the billing. So the rate at which you are charged for using the front end service might be different from the rate at which you might be charged for the back end service, because back end, after all, there will be a lot of overhead in the network. There will be response delays, and so you should not be unjustly charged massively for that backend service at the same rate as the front end. So there are discrepancies because of the nature of the networks involved. But the idea is that ready-made environments has led to a massive growth in business applications on cloud, because it is possible to create applications on the fly without knowing too much of code, without of getting into the too much of the networking and complete abstraction, which is possible through virtualization. So this is the real sense I want to project, that virtualization has made for me, the way I look at the whole industry moving, it has made two impressions. One is the ability to scale, whether we scale on the infra or whether we scale on the application. There is a tremendous impact, and it has accelerated this scaling part. The other aspect is the ability to, the agility in computing, what we say, right? So we build applications on the fly. We have n number of applications, software applications which are running on the internet, and these are only possible through these ready-made environments, because everything is provided to you as a platform. It is virtualized, and you just need to be focused on your business, the business which you are into, and growing that business. So these are the some of the great impacts of virtualization. Let me just give you a picture of the view, how it looks like in real world. If we have an application which has two, like we were discussing, these are two groupings. One is for the front end, one is for the back end. And imagine that these are ready-made or platform as a service. So they have a software development kit, they have a runtime environment, all of this. So what happens here is the consumer is accessing these services as ready-made services and are getting billed for it. Okay, and the billing also, the virtual services scaling, the billing also is related to the type of infrastructure, the type of the runtime that is being used. So everything is possible. I mean, you can actually do the billing based on the type of component that you use. The virtual server scaling, so the fundamental, how does it actually happen? So just to give you a sense of the scaling, you see there is a hypervisor which is for the virtualization, and there are scaling listeners that are used. These are softwares which are positioned on the hypervisor, and their main function is to notify the underlying or notify the VIM, virtual infrastructure manager, that look, there are more requests to be handled, more traffic to be handled, we need to create more virtual machines. So this is a typical flow, that you have a requester who is operating from the usage portal, provisioning new, sending in new requests for provisioning of virtual machines and virtual memory. And behind the scene, the hypervisor and the VIM are making all these virtual machines here to satisfy the number of requests which are coming from the consumer. So scaling is done primarily using the hypervisor and the hypervisor listener. This is a small, introductory sort of thing on load balancing, because the fundamental thing in network of cloud is you need to scale, and you need to ensure that none of your infrastructure resources are overloaded at any point in time. So if you look at the flow, I have a consumer service, which is, say, for example, service one. And then behind that service is hosted on this ready-made environment, as you see here. Could be a front-end service. And there are multiple instances of that service getting created based on the type of, based on the request. So you can actually scale your service as well as the infrastructure or the virtual machines or the ready-made environment. It's really the question of your architecture, how you think of scaling your application and scaling your infrastructure. There is something called from an infrastructure point of view, this is very important because any service has to be kept operational. You need to have an SLA on the virtual servers. So an SLA monitor, like we were using a monitoring agent to keep tab on the usage of the virtual server, the same tab can be maintained here as well. And you can you can keep tab of these things. So this there are plenty of monitoring agents, monitoring services in use in the industry. Amazon has something called a CloudWatch. DevOps, Azure has, Microsoft has Azure Monitor. So primarily they are used for measuring the usage of infrastructure, how the infrastructure, the virtual machines, the CPUs, the RAM, the network, the disk storage, all of these are being used. So with this, I kind of end my short note, but please let me know for any questions. I know the topic had multiple dimensions to it, but essentially it's all about how virtualization has created a big impact in ability to scale and ability to replicate. So these are the points I wanted to cover. Thank you.
Thank you, sir. Thank you, sir, for such a thought-provoking session. And I'm sure everyone present here really valued the knowledge you shared and are the most appreciative of this session. So now further, we'll have our question and answer round. So if anyone have any question and anything to discuss with sir, any query they can ask. Any student or the faculty member? I hope things are clear to them and they don't have much to ask because sir, already you have clarified everything in such a detail. So on this note, we have entered the final moments of our session where I feel privileged to propose a vote of thanks. First of all, I would like to thank our Department of CSE, AI and ML, and Cybersecurity and Futurance Technologies to conduct a wonderful event of Industry Connect, where our students with faculty members are fortunate to connect with eminent industry experts of various domains. On behalf of the Department of Computer Science and Engineering of Jain, deemed to be university, and all the students, I extend a very hearty vote of thanks to Mr. Chakraborty to accept our invitation and for refurbishing our students with the best possible and upgraded education. And I must mention a deep sense of appreciation to our beloved HOD, Dr. V. Vivek, for his constant support and motivation. I sincerely thank our team of very motivated and hardworking faculty members to join this session. And finally, I would like to thank our students for paying their valuable attention. And once again, I would like to thank all of you. And thank you, sir. Thanks a lot for joining.
Thank you so much.
Thank you, sir. Students and the member of the meetings, I have shared the feedback form for the session. Kindly take a 2 minute of time and just fill the form.